Hi, can everyone hear me all right? It's good? All right, cool. Hi, yeah, so I'm Chris Donahue. I'm a PhD student at UC San Diego, and today I want to talk about Piano Genie, which is a project I did while an intern at Google Magenta with my host Ian Simon and a collaborator, Sander Dieleman from DeepMind. I want to start off by talking about the traditional approach to music generation. Piano Genie is ultimately a music generation project, so I want to look at kind of the context here. So much of the research in music generation thus far has been conducted under what I like to call the big red button framework, where ultimately the goal of projects in this framework are to build what amounts to a single button that you can push to just generate music in a vacuum. And I'm going to argue that this is problematic because it removes humans from the loop of what is ultimately a very human phenomenon of music creation and music enjoyment. And furthermore, the limited ability of someone to actually intervene and manipulate this generative process in any meaningful way results in the person who pressed the button feeling very little sense of ownership over the resultant music because all they did was press a button. So in this talk and in my research in general, I'm advocating for an interactive music generation framework where the goal here is to build systems which are largely driven by human gestural controls specified through some sort of intuitive interface. And then the systems, usually machine learning systems, will accordingly produce music that kind of corresponds in some way to the gestures specified by the person. And this keeps humans in the loop and ultimately, produces systems that are frankly just more fun to use. But furthermore, the fact that someone was kind of still in the loop, making the decisions, pulling the levers, results in the person who actually piloted the interactive music generation system feeling a lot more of a sense of ownership over the result. So I think these systems are especially powerful for building these types of systems are especially powerful if we're targeting people that are not experts in music. Because currently, non-musicians really only have can only interact with music by means of listening to it, essentially. So it'd be really great if we could actually build systems that allowed non-musicians to create music as well as listen to it. So I'm advocating not just for interactive music generation frameworks, but for ones that actually can be operated by non-musicians. So for example, could we build a system which takes someone such as Beavis here playing the air guitar and automatically extracts gestures from that performance and translates them into corresponding gestures that St. Vincent might play when playing her actual real guitar, kind of thereby allowing someone who doesn't know how to play music to participate in the creative process. And this is something that is really important to me as someone who feels lucky that creating music has brought them a lot of joy throughout their lives, but also doesn't feel like this joy should be restricted to the people who are fortunate enough to learn how to play an instrument. So Piano Genie is another such project in this space. And essentially, we were kind of inspired by Guitar Hero, if some of you are familiar with the game. And Guitar Hero is this game that allows you to kind of respond to guitar playing and music that you enjoy by means of kind of imitating a rough outline of what the guitarist is doing on a simple controller. And we wanted to ask the question of whether or not you could kind of do the opposite, like actually create music using a very simple and intuitive controller rather than just respond to it. So we built this little controller here consisting of 8 buttons, basically just little arcade buttons. And essentially what we want to do is decode in real time performances on this 8-button controller to corresponding performances on a full 88-key piano keyboard, thereby giving people who don't know how to play the piano some amount of improvisational literacy. So we have a real-time web demo that you can try out on yourself, by yourself rather, and I'll switch over there and do a brief demo now, which might answer a lot of the questions. And if you don't have the button controller, it's fine. You can use the keys on your keyboard, 1 through 8. So Piano Genie essentially works like a regular piano. If I press 1 button, I get 1 note. If I press 2 buttons, I get a chord, 3 buttons, a chord with 3 notes. And so in Piano Genie, the pilot, so to speak, is in full control of the rhythm of their performance. And they have partial control over the shape of their performance, by which I mean kind of the overall shape of the melody. So if I press a higher button, I should get a higher note. And if I press a lower button, I should get a lower note. And basically, any other gesture that you can think of that would be plausible on the piano works pretty intuitively in Piano Genie. So I'll just do like a little brief kind of improvisation. So you get the general idea. You can feel free to try this out on your own computer. But let's skip back to the slides now and talk a little bit about how we got there. So what we started out with is a data set consisting of piano performances by skilled pianists. So we have a data set consisting of a few hundred digitized piano performances. And they essentially look like what you see here at the bottom. So basically sequences of integers, 1 through 88, because there are 88 keys on the piano, that represent the kind of the order of notes that the skilled pianist pressed. But what we don't have, unfortunately, is a sequence of corresponding data of performances on our 8-button controller. So we don't really have much of a way of treating this as like a supervised learning problem. So to sort of circumvent this issue, we adopt an auto-encoding approach. So basically, what we do is we take slices of real piano music and feed them through a recurrent neural network, which outputs equal length sequences of not piano notes, but instead buttons, 1 through 8, so essentially a sequence of integers. And then a decoder is tasked with taking those button sequences and reconstructing the original piano music. So kind of basically the autoencoder structure we've set up here is sort of aware of the downstream interface that we hope to use. And so we train this entire thing end to end to minimize the reconstruction error of the decoder, which basically forces the encoder to preserve most of the information about the piano music in the button space. And then our intended interaction is to replace the encoder with a human performing on the buttons. So now, every time the user presses a button, we will quickly query the RNN to produce a prediction. And then the next time the user presses a button, we will feed in not only the new button that they pressed, but also the previous output of the RNN so that the model can actually create sequences that have sort of contextual similarity. But one thing you might notice is that there's nothing about this model that's enforcing this property that the shape of the buttons should correspond to the shape of the music. So we come up with a regularization strategy which allows, which encourages the encoder to produce button sequences that correspond to the shape of the piano sequence. And then accordingly, the decoder will learn this policy so that when a person is actually playing on the thing, it will obey these semantics. So we conduct a user study to kind of get a sense of how well this thing works. So basically what we want to do is we want to compare 3 different mappings between our 8-button controller here and an 88-key piano. So the first mapping that kind of our baseline mapping is a simple major scale where essentially we map the 8 buttons on the keyboard to 1 octave of a major scale. And in this mapping, a user has to rely on their own musical intuition to produce patterns of interest. We compare this to performance RNN, which is a model previously developed at Magenta, which essentially is a model which is trying to predict notes that human pianists are likely to play, ignoring anything having to do with the buttons. So there, all we do is that every time someone presses a button, we query performance RNN for a note prediction and output that note. Basically, at a high level, this model gives the user control over the timing of their performance, but not the contour or the shape of their performance. And then we compare this to Piano Genie. So overall, users report enjoying Piano Genie substantially more than the other 2 mappings. And they also report that Piano Genie gives them more perceived control than performance RNN, where we're claiming Piano Genie has this additional ability to control the shape, but less control overall than the major scale, which is actually a deterministic mapping. But backing out a little bit, I kind of see this as kind of a single example of this broader idea of grab and play mappings, which was proposed by Hugo Scurto and Rebecca Fiebrink a few years back. And I really like this idea. Basically, the idea is that we should be able to pick up any kind of arbitrary thing that we have access to, like this clicker here, and bang it on a table, and automatically extract gestures from that performance and map them to gestures of another sound synthesis algorithm. If you could call Questlove playing his drum set a sound synthesis algorithm. But basically, it'd be a really nice property to be able to use any arbitrary controller to control any arbitrary music software. And furthermore, I think this is kind of a more broadly applicable idea of building arbitrary interfaces for complex tasks. So for example, could we take this train conducting interface thing and use it to control Photoshop? basically like automatically figure out a mapping from that interface to this complex task. And there's a potential benefit here where, for example, if a train conductor spends most of their day operating this interface on the left, they might have a substantial amount of domain knowledge and muscle memory, which would be really great if we could transfer that to a new task, which might lower the barrier to entry for that task for someone with experience on that interface. So with that, I'll say thank you. Please try out our demo and feel free to contact me by email if I don't answer your question here. So thank you.
Thanks a lot. We have 5 minutes for questions before they kick us out.
Thank you. I think it's a very cool tool. I have one question, though. How difficult is to reproduce the same song twice as a user?
Yeah, so kind of the original outset of this project was to build something that allows you to like kind of intelligently remix a song. Like, so for example, if you could take some piano song, encode it into buttons using the trained model, and then additionally have some other like continuous attribute that might describe the style of the song or something, such that a user could then learn the correct button sequence and basically play the song on this very simple controller, kind of similar to like Guitar Hero or something. But at some point, it became a pretty challenging task from an interface perspective to design that. And so we switched to just this like fully improvisatory model, where currently the model is basically, it's not possible to reproduce the same thing twice, and it's fully improvisatory. And in the future, we hope to add in like contextual conditioning so that you can kind of, reproduce things or integrate with existing music, et cetera.
Many thanks, very cool work. What I wondered is, what about going into the other direction? So I think what connects people to their own music is that they have to invest a lot of effort. So like spending 10 years, 20 years into learning how to play the piano. Mm-hmm. And they can do that on a very high level. And what about like enabling these people to achieve even higher level, like getting the timing exactly right, or being able to play 2 instruments at once? So I'm able to play piano very well, but I cannot play piano and another instrument at the same time. So going for people that are extremely good in playing instruments already, to put them on a different level.
Yeah, I mean, I think that's an equally compelling idea. I'm particularly interested in systems that can be operated by non-musicians, primarily because 99% plus of people are non-musicians. So like the opportunity to actually build things that enrich more people's lives are there if you kind of target non-musicians. I also think that kind of in general, musicians are constantly pushing themselves to do crazier and crazier things with instruments. So I don't know. I feel like in general, people might not be so receptive to the idea of like a machine learning system improving them as a pianist. Maybe they would be. I don't know. But basically, my response is that currently my main focus is on systems that non-musicians can use, mostly because that's most people. Yeah. I think there's one over here.
Thank you for the fascinating talk. I have a question that's in 2 parts. One is just a sanity check to frame the second part.
Okay.
The first is regarding the autoencoder.
Uh-huh.
So is it that there's a t-tuple, and where each of the variables of the t-tuple are between 1 and 88 for the keyboard?
Yeah.
To a t-tuple of 8, resolution 8, and then
exactly.
back to okay.
Yes.
So
it's basically just compressing, an 88 vocabulary sequence into an 8 vocabulary sequence.
Right. So I'm wondering, just your thoughts on how it would be to incorporate 9 buttons where one of them is a non-press.
I see.
Because then instead of encoding a note being played, you could also incorporate some temporal information as well. But I just wanted to know if this was like already attempted and failed, or...
Yeah, that's a really good question. So we considered a lot of different potential mappings between, our controller and the keyboard. some of which weren't exactly what you mentioned, but basically like loosening the contract of one button corresponding to one note. So that contract actually came about because as a pianist, I really wanted that functionality to be preserved. Like I wanted to be able to press exactly 3 buttons and hear exactly 3 notes, like no more, no less. But as we started experimenting, as we started putting this thing in the hands of people that were not pianists, we often got the feedback that many people would have preferred a non-direct mapping, like if they pressed a button, they got a chord, or like maybe even a run of notes or something. So specifically, we did not try the exact setup that you mentioned. But kind of our hope for the future is to kind of loosen this contract so that so that people can, you know, press one button and get multiple notes, but specifically so that we could tailor that on a user by user basis, so that people who, you know, maybe have more piano experience and want things to behave in certain ways can achieve that, and others who have less experience and want things to kind of magically happen for them can also achieve that. So I think there's work still to be done on satisfying a lot of different expectations on the user end.
Yeah, that's what we are all trying to do.
Right.
Okay.
Yeah.
Chris, thanks a lot again. Let's thank the speaker again. And